In software engineering, there's a common belief. Better tools solve bigger problems, more powerful database, more flexible systems, more advanced architectures. But sometimes, the more powerful the tool, the harder it becomes to operate at scale. Welcome to Yond Studio, where we break down the real decisions behind the world's most important systems. Not just what changed, but why it changed. Let's dive in. At one point, Uber relied heavily on PostgreSQL, a powerful, flexible, feature-rich database. On paper, it looked like the perfect choice. Strong consistency, complex queries, advanced indexing, rich relational features. But as Uber scaled globally, something unexpected happened. They started moving away from Postgres and towards MySQL. Not because Postgres failed, but because of something deeper. Something most developers don't think about until it's too late. So what actually happened? Let's start with the real challenge. Uber isn't just an app. Uber is a real-time logistics system. Every second, driver updates their location, riders request trips, prices recalculate, payments process. Each ride generates dozens of database events. Now multiply that across cities like San Francisco, London, New York, Durban, Lagos, and then across hundreds more. Suddenly, you're not dealing with a database problem. This is a continuous high-frequency real-time data processing. User, API, database, response. Simple. But under scale, not so simple anymore. Postgres, it's excellent, but Uber's challenge wasn't query complexity. It was write volume. At massive scale, a problem emerges. Million of writes, single write path, a bottleneck. Even a powerful database can choke under extreme load. As traffic increased, write throughput became critical. Replication lag appeared. Cross-region scaling grew difficult. Postgres scales vertically really well. Big server, more power. But Uber needed horizontal scaling, more server, distributed load, global reach. And that's where things got tricky. Maintaining large Postgres cluster isn't easy. Complex application setups, failover challenges, turning from high write loads. And when failover happens, debugging is slow. Fixing issues under load is painful. Powerful, yes, but operationally expensive. So what did Uber do? They chose to build. Uber created a system called schemaless. The idea? Instead of one database, use many. A visual design of schemaless. Each node stores a part of the database. This is called sharding. Now, instead of scaling vertically, you can scale horizontally. Add more servers, handle more traffic. In theory, unlimited scale. And for a while, it worked. But distributed systems introduce a new problem: complexity. Now, instead of managing just one system, you are managing hundreds. Failures became harder to debug. Data consistency became tricky. Small issues became system-wide problems. And here's the key insight. Scaling the system also scaled the complexity. Eventually, something shifted. Engineers weren't just building features anymore. They were maintaining infrastructure, fixing edge cases, debugging distributed failures. The system worked, but it was expensive to operate and slow to evolve. That's when Uber asked the difficult question. What if the goal isn't maximum scale, but manageable scale? Instead of abandoning relational database, Uber rethought their approach. They built a new system around MySQL again, but this time with better tooling. The system became Store. MySQL handles storage. Store handles distribution. Engineers manage less complexity. Results predictable, reliable, horizontally scalable systems without the extreme overhead of maintaining massive Postgres clusters. This story isn't about databases, it's about engineering trade-offs. In tech, we often choose new tools, complex systems, cutting-edge architecture. But at scale, the most valuable thing is innovation, is predictability. This is why even companies like Uber still rely on systems like MySQL. Because the hardest problem in software isn't building a system, it's running them reliably. And this raises a big question. If one of the most advanced engineering teams in the world moved back to simplicity, how many other companies are quietly doing the same? At Yond Studio, we don't just follow tech decisions, we break down systems behind it, because once you understand the systems, you start to see the future. If this gave you a new perspective, stay with us. There's always more beneath the surface.